Okay, hello guys. Today we are talking about the lines and circles problem. Okay, so let me do the first slide about it. So we already know that for the lines equation is y equals to mx plus c, right? And for the circles equation is x minus a squared plus y minus b squared equals to r squared. Okay. But then if you want to find the intercept with each other, you can just try to substitute it. Okay, so for example, like you can just try to let y equals to mx plus c into this equation. So you can find here, it turns into x minus a squared plus mx plus c minus b squared equals to r squared, right? So then you can expand it as the m squared plus 1x squared, and then is minus 2ax, and also for minus 2, sorry, plus 2mc minus bx, right? Plus a squared plus c minus b squared equals to r squared, okay? So you can find, you can just try to simplify it as a final form. It's a quadratic equation, right? So you can just try to solving the quadratic equation. And we need that for quadratic equation, here is a discriminant, right? So we have three situations. The first is discriminant bigger than zero. That means there are two intersections right here. And if the discriminant equals to zero, that means there's only one intersection. And maybe when the discriminant is smaller than zero, that means there is no intersection, right? And it means like low roots, okay? So we're just trying to use an example to show you how is that. So the problem set find where y equals to x plus 1 meets x squared plus y squared equals 25, right? So you can just try to substitute y equals to x plus 1 into this equation. So that can be written as x squared plus x plus 1 squared equals to 25, right? And then you can try to simplify it as x squared plus 2x plus 1 equals 25. So you can just try to set that is for x squared plus x minus 12 equals 0, okay? And you can easily find that it can be factorizing, right? Like here, 12 can be written down as for 4 and negative 3. So it can be written as x plus 4 times x minus 3 equals 0. So here we have two reads right here. That is for x equals to negative 4 or x equals to 3, right? So because here we have two intersections, right? Okay. And also we have an alternating method for the tangents. Okay, so right here, I have to show you that the distance from the center to the line. Okay, so here, maybe we have the x, y, y, y is a point. We want to find the distance to the line ax plus by plus c equals 0. So we are just trying to substitute x1, y1 into the equation. So that can be written as a times x1 plus by1 plus c, and then over the square root a squared plus b squared. Okay, that is the alternative method for the like the lines, and you can just trying to find the distance of it. So you can find this represent for distance. So if it equals to the radius r, that means it have only one intercept, right? And if smaller than r, that means maybe there's a circle, there's a radius, and the distance to the central to the line is smaller than radius, that means there are intercept, right? They have two intercepts, okay? And maybe if the distance is bigger than radius, that means it is out of the circle and there's no intercept, okay? So here also we have an example for tangent, like for 3x plus 4y plus k equals to 0, and trying to find if the tangent for x squared plus y squared equals 25, right? So in this circle, we knew that it can be considered as x minus 0 squared plus y minus 0 squared, right? But the simple point is 0, 0. So the distance from 0, 0 to the line can be written as 3 times 0 plus 4 times 0 plus k, and then you can divide it by the square root 3 squared plus 4 squared, okay? That is it. And then you can say, okay, maybe just trying to simplify it and you can find the final value equals to 5. So we can say here that the value k equals to 5 means the distance equals to 5 and distance equals to radius. That means they have only one intercept like here, right? The central to the distance equals to the radius. That means there's a tangent, okay? Okay, so here is for the student exercises for you. So you can just try to solving it yourself. But if you want to follow with me, you can keep on going, okay? So the first problem is determine if the line y equals x plus 10 intersects the circle. You can just try to substitute it, right? As x squared plus y can be using as x plus 10 squared equals to 8, right? And then you can just try to simplify that 2x squared plus 20x plus 92 equals 0, right? So x squared plus 10x plus the 46 equals 0. And then you can just try to using the discriminant equals to b squared minus 4ac, right? You can find the value is smaller than 0. So that means there's no intercept, okay? That is for the first problem. And then for the second problem, you want to find the tangent. So you can just try to first simplify it as x plus 1 squared plus y minus 5 squared, and trying to find the value. Here it is for 25, 26, and it's 5, right? So you can just try to find that here's the central is for -1 and 5. So you can find the distance between the central point to the lines, right? So it can be written as y minus 2x plus 5 equals to 0. So just trying to using the formula we said before, that is for a 5 minus 2 times -1 and plus 5 and over the 1 square, here's 1 square, right? Plus here's for -2 is -2 square, right? Okay. So because that the value here is 5 plus 2 plus 5 is 12, and this value is for square root 5, okay? And just compare with a radius square root 5, you can find this value is quite bigger than square root 5, right? So that means the distance between the line and the central is bigger than radius, okay? That means there's no intercept. So this is not a tangent, okay? These are these problems. So that's for this our lesson. Hoping you can understanding for how to calculate the values. So see you next time. Bye.